Okay, let's get started. So today we're going to discuss the fundamentals of SQL. I think yesterday also a couple of participants were asking like, we are from non-technical background, so SQL, is it the right course for us? Or will I be able to learn, right? So many questions there. So I'll be answering all those questions today in the introduction to SQL. So you really no need to come from the technical education background to learn SQL. But definitely, a few data fundamentals are very much needed. And that's the reason yesterday I was checking about whether you are aware of Excel features or not. Like what is Excel spreadsheet, what is data, how it is stored in the tables, how to write formulas like lookup formulas, sum if formulas, or pivoting, right? So if you are aware of those kind of concepts, then it's easy for us to learn SQL. Because in SQL also you find very much similar functions. Okay, fine then. So today it's only about SQL introduction, right? And Monday we will do the SQL Server installation and the client installation. Okay, so certain things are there. Let's start SQL. So we call it SQL or we call it SQL. It's basically SQL, structured query language, and it is pronounced SQL. Okay. So why, as a data analyst or a reporting analyst or MIS, analyst, or for that matter, for any kind of a data analysis role, why SQL is most common skill? Very simple. If you want to create any report or for any analysis, okay, what is needed? Data is needed. And the data is usually stored in different forms, right? Something like Excel, CSV files, PDFs. But hold on, these are the file system files. But when it comes to a big organization where they need to store millions or maybe billions of records, it's not possible for these simple files to store that much of data and manage. So what they prefer a database. It could be any kind of a database. It could be a SQL Server database, Oracle database, or MySQL database, Teradata, DB2, SAP HANA, whatnot. There are so many things like this. Depends on the company's requirement and the kind of cost effectiveness also of these tools. Basis on them, they choose the different tools and basis on their company priorities. Okay, so here we go. If the data is stored in the database and you want to create a report, then what is needed? You need to extract the data from the database as a reporting analyst or a data analyst. It could be a financial data analyst role, HR analyst role, or operations analyst role, and anything. You need to interact with the database and get the data, and then only you create the report. A simple example, let's say you are working with HR team as HR analyst, and your management asks like, okay, find out the attrition rate. And all the details are there in the database tables. Okay, if the data is there in Excel, you can simply write a few Excel formulas and you get that output. But if the data itself is there in the database, what is the first thing you need to do? You should be able to extract the data first. So that is the reason for a data analyst, SQL becomes a very mandatory skill. Because you can't depend on any other team to write the SQL query and get you the data and then you create a report. It's not possible these days. Earlier it was there. SQL teams were different, reporting teams were different, but now it is combined. Okay. So if you want to create any report using Excel or Power BI, Tableau, or ClickSense or ClickView, you need some data and the data is there in the database. And in order to interact with the database and get you the data, you need a language. There are certain techniques without SQL language also you can still get the data, but let's not look into that technique at this point. Let us think about you want to extract some data from the database to create a report in Power BI. Data is here in SQL database and you want to use here SQL and get that output. Okay, you just get the data only. While getting the data, there are so many things. You can summarize the data, you can group the data, you can different things, aggregations or pivoting, unpivoting kind of techniques. So many things we can do. Done. So we understood the importance of SQL because without this language, you cannot interact with the database. Right? That's the reason yesterday when I was showing you about the different positions that are open, right? The different positions that are open, I was just searching for the Power BI roles, but in almost every role, though the title says Power BI developer, but what are the skills expected there? SQL is mandatory, proficient in SQL. Right. Okay, fine then. So we understood the importance of SQL because anything you want to get up, get it from the database, SQL is needed, and we also need a server. Okay, here we are going to use Microsoft SQL Server. I'll talk about what is a server, what is a client, and all that. But let's keep it very simple for now that it is a language we are going to learn, SQL language, right? It's a querying language, you can say, right? Using which you will be able to get the data. And I always talk about how to extract the data only. There are other things like you can develop the database, you can create ER diagrams, you can set up the security rules, you can create the users, right? So many other things are there, but that they are not our responsibilities. Usually they are taken care by some other teams in the organizations. Our job is to interact with the database, extract the data, create a report, draw the insights, help the business to understand what's happening. That's it. Okay, fine then. So let us take a look at introduction to SQL. Why should I learn SQL? Most of you may have this question. Like I'm already working as a data analyst using Excel and everything is going good, right? So why do I need to upskill myself? Okay, here we go. If you're just simply using Excel and you may be working as a data analyst or MIS analyst in an organization, maybe for that company, that skill may be enough. But when you are looking out for a good opportunity, definitely, when you start searching for them, what is the other skill that you are commonly looking at? SQL, right? But not every company, can store their data just only simply in Excel files or CSV files. There are databases, okay? You should understand the structure of a database, okay? Done then. So to understand the data and generate the reports as per our requirements. So once you learn SQL, this is possible. Reduce dependency on IT team for getting latest data. So you no need to reach out to any IT team requesting for, okay, I need the latest data. Please, can you write a query and share it? No, you no need to do that because if you are aware of SQL, you will only be able to write it. Right, perform better than peers and get recognized. Obviously, when you have that additional skill, then you will be able to do better than your peers, right? And then be more employable. More skills, more opportunities. It's as simple as that. As an analyst, you know the requirements very well. You will be able to write a better query. Simple. Usually what happens is that in the client calls and all, they, the client, from the business standpoint, they request the data analyst to be present in the meeting. Because whatever client is saying, you should be able to understand and turn that into a query and to get the data, right? So let's say you go there, you get the requirement and you talk to the client and you understand the entire business context there and you get, you gather the requirement. Let's say this person who gathered that requirement is not an SQL expert. Then what this person needs to do, needs to reach out to the IT team and explain the same thing to IT team to get the data. What if IT team understands it in a little different way? They write a different query and they get you the data. And when we create the report obviously looks incorrect. Why? Because the data itself is incorrect, right? So understand this. Instead of this particular thing, if someone learns SQL, what is the advantage there? Okay, this person sits in the client call, understands the business requirement, understand the context, why this client is asking for this particular report, and then go back, write the query because this person understood the entire requirement, right? And then write the query, get the data, create a report, that's it, done, right? So because we work as an analyst, we understand from both technical standpoint and the business standpoint. Okay, business standpoint, the client will be explaining us like, okay, why are we looking for this data? From the technical standpoint, we already have some idea about the database and we know how to generate that report, right? So it is recommended as an analyst, one should have SQL skills. Aggregate functions like sum, count, average, and all those complex functions can be implemented at your query level itself. While writing the query level itself, it's just not only sum, count, and average. Okay, so you may be thinking sum, count, and average can be implemented at Excel also, right? Why do I need to worry about implementing these things in SQL? Understand one thing, there are certain things, even if you want to do the sum, the complexity of getting the sum of that value is going to be really, really high. Because you are looking at for a particular job grade and in a location and you want to get the sum of salaries under certain conditions. These things, of course, can be implemented in Excel also, but certain things in Excel, implementing them is very, very challenging because of the functions limitations. But the same thing can be implemented very easily in SQL. Okay. So that is possible instead of writing very complex Excel formulas. Of course, you can still achieve that output in Excel also, but the formula looks very, very complex. But in SQL, it is going to be achieved very easily because different functionalities are there. All right, you will be able to easily understand the data modeling concepts for the data analytics tools like Power BI, Tableau, ClickView, ClickSense, and all these tools, whatever the data models that you create, they follow the same rules when you learn SQL. Whatever the rules that you learn there, the same rules are followed by these tools as well. So that's the reason after learning SQL, understanding Power BI data modeling concept is very easy. Okay, all these things are there with SQL. So in here we speak about primary key, foreign key, unique key, different constraints are there. Using these constraints only, we create the data models. Okay, right? Yeah. So that's why we need to learn SQL. What is a database? Simple. Database is collection of data which has some relationships. Simply, any collection of related information, okay, is a database. It could be a phone book, right? It could be a shopping list or whatever it is. You name anything that has some related information, you can call it as a database. No need to, consider. A simple example could be, what I'm trying to say is no need to just consider only the business data is stored in the database. No, you can store your personal data also in the database. But the only thing is that it should be some related information. Okay. But where do we store these databases? The moment we think about a database, always something comes into our mind. What is it? A computer. But hold on, database doesn't, need to be always stored on a computer. You can take a pen and paper, write in a structured manner the related information. You can consider that as a database, right? Or you can use your mind. Our mind is our database. Very dangerous database. Usually forgets all the important things and remembers all the unnecessary things, right? Okay, so yeah, our mind is a database, but the business transactions and all, we do not recommend someone to store all of them, in one's mind. Because what if very, important transaction is forgotten by the mind? You get the point. So that's not the right place to store everything. Yeah, on a computer, recommended. Why? Because computers have the storage devices like SSDs or NVMEs or anything. And these days, these databases are the cloud-based databases. Nothing but data won't be physically present in your computer. The data may be stored somewhere else, but from there you can access it via internet, right? But ultimately it is stored in some drive, some place, right? So what is a database? Any collection of related information is a database. And where do we prefer it to be saved? On a computer, because we have different memory devices inside the computer, right? Okay. So I got some idea, right? What is a database? Database could be anything if it is a related information. That's it. What is the best place to store it? On a computer. It could be locally stored in my laptop itself, or it can be stored somewhere, but I can still access the data with the help of internet. Okay. So coming to the technical definition of it, a database is a collection of data objects that are used to store and manage the data. Data objects, right? Data objects. There are so many things in the data objects. You consider for now tables and views. Enough. There are other things also, like you have stored procedures, triggers, indexes, synonyms, and so many other things. But tables and views are the very important things. These two are very, very important things for the data analyst. Tables and views. So database is a collection of different data objects, and in which we find the tables and views. There are other things also, but tables and views are very important things for the data analyst. Right. So when it comes to a database, a CSV file, Excel file, Access, SQL Server, all these things you can consider them as databases only. But there is a slight difference between the first I mean, the first two and the other three. Okay. CSV file, Excel files, yes, they can be used as a database, but they are not served by any database server. There is no server for these two because these are the file system files. These are simply individual files, CSV files or Excel files. Of course, they can store some data. You can consider them as your database, but they are not really databases because there is no database server involved. There is no server application for this. Okay, these are simply file system files. Simply files, that's it. The other three, Access, SQL Server, or Oracle, these are actually the databases. And moreover, the common thing is all of them are RDBMs, relational databases. Access, SQL Server databases, Oracle databases, all of them are RDBMS, relational database management systems. Right, they are managed by a server, which is RDBMS, relational database management system. Okay, relational databases, you can say. Why do we call these three as relational databases? Because the information is stored in the form of tables that have the relationships. We'll talk about that in the next slide, okay? So what are the two file system files here? CSV file and Excel file. Of course, they can be used as databases, but there is no server involved. So these are only files. These are not actually databases. But if you talk about a database, MS Access, you can say, SQL Server databases, you can say Oracle, DB2, Teradata, SAP HANA, you have PostgreSQL. Different databases, other databases are there. But yeah, for example, we are talking about only three. And by the way, MS Access, this one and this one, both of them are from Microsoft only. Okay, MS Access. Where do you find MS Access? Yeah, MS Office package itself, right? So there is a RDBMS in MS Office package itself. For small applications development, we use MS Access. For a bigger one, where you need to store GBs of data or TBs of data, then it is recommended to go with the SQL Server database or Oracle or any other database. But small teams and all, they go with MS Access. Okay. Then what is SQL? Structured Query Language, pronounced SQL. And this is the language using which you can talk to the database. Okay. You can interact with the database, you can input the data, you can extract the data, you can update the data, you can delete the data, you can create a new table, you can drop a table, you can alter a table, you can create a user, right? All these things are possible with SQL only. So I'll do one thing, I'll just show you one example here. And after that, yeah, you will get the clarity about what is SQL and what is SQL Server, okay? So basically it is a media through which we, using which we can interact with the database server and, store the data and retrieve the data. Different things we can do with SQL. Structured Query Language, SQL. So there is always a confusion. Even initially I used to have this confusion. People call it SQL and also SQL Server. What are they? Are they two different things? Are they same? SQL and SQL Server are the same? Or what is it? Okay. To understand this difference, and with that, you will get a better clarity. What is a server? What is a language? What is a database, right? I'll do one thing. I have a presentation with me. Okay, here we go. Let's go to SQL restaurant. Okay, where data gets served. Right. Let's take an example of a restaurant here. So for some time, let us come out of that SQL and all the technical terms, come out of it, and let's talk about a restaurant example. Let's say you want to go to a Hyderabadi restaurant, right? Okay, fine then. Look at the restaurant that has a board and the entire building is there, right? So you step in, you find a table, you sit there, right? And you looked at the menu and you liked a couple of things. Now you want to order. Okay, what is that you do? Okay, you call the staff, right? But you don't directly go to the kitchen and order, right? Yeah, you sit there only. You call the staff. Perfect. Can you name the staff? What do we call that staff? Waiter. Waiter. Any other alternative names? Bearer. Okay. Any other? Go on. There is one more name. Okay. Look at the screen. You'll find the answer. There is a name. Server. Perfect. Server. Yeah, you can. Who serves the food? Right? Okay. You call the server and you look at the menu and you say that, okay, I want, it's a biryani, chicken biryani. Done. Okay. What is the job of the server now? Takes the order. Goes to the kitchen. Perfect. Right. Tells table number 12 wants chicken biryani. Done. And in the kitchen, the food gets prepared and the food is handed over directly from the kitchen to you, or the server is involved again. The server is involved. Perfect. The server will go there, takes the food from the kitchen, comes to your table and serves the food. Done. So one transaction is over. Right? So what will happen here, basically, you looked at the menu, you found one item and you spoke to server like, what is that you wanted? And server went there, got it prepared, came back and delivered the food. That's it. Done. It's one transaction if you consider. Right. So let us talk the same example, right? In the restaurant side, what all terminology that we use, the same thing if you turn that into SQL side, who all are there, what are the names and all we'll discuss now. So it is SQL restaurant where the data gets served. Done. The big picture here, consider your entire restaurant is equal to your database entire environment there. Okay. In the restaurant, what is it we see? Physical building, right? Contains everything is needed and the organized team at the system, right? All of that. In the database, you have the server environment, it stores all the data and structured storage. Okay. So let me do one thing. Let me just turn this into a bit more easier way to explain this. Let's say when server comes to you, let's say you sit on a table 12 and server comes to you and you talk to that person, right? Because you need to get your order processed or whatever you wanted to have them. Server comes to you and I said it's a Hyderabad restaurant, right? Okay. And you start talking to that person in Spanish. Will the server be able to understand? No. So what is the language you prefer there? English, Telugu, Hindi, Urdu, right? Hyderabad restaurant. Okay, done. So here we go. So that means you need to talk to the server in a commonly understandable language. Yes or no? If you are using any other language, you can't. I mean, that server can't understand it. Similarly, when you talk to that server, you are using a common language, right? So that is understood by both of you. Here, as a client, who is a client here? You are the client. And who is the server who is actually taking your request there? And in which language I need to talk to that person in a commonly understandable language. Here we use like normal spoken languages like Telugu, Hindi or English. So on the SQL server side or any database side, what is a commonly understandable language there? SQL. Perfect. So a client talk to the server in a commonly understandable language is SQL, structured query language. There are different variants of SQL. Let's say you have TSQL, ANSI SQL, Oracle SQL, right? MySQL, yeah. So different variants of SQL languages are present, right? But you no need to worry about them. The reason being, there are slight differences, but majority of the things they look same, right? A simple example. Let's say you have decided to talk to that person in Telugu. In Telugu also we have variants, right? But good thing is that most of the content remains same, but the slightly, the words and the selection of the words and, the way you frame the sentence and all may be little different. But overall, the sentence formation and all that has the same standard, right? So here, when we talk about the different variants of SQL, you no need to worry about that, because if you learn one variant of SQL, you will be able to write other variants also, right? A simple example. Let's say you visit a Hyderabad restaurant and you speak to that person, in let's say Rayalaseema Telugu accent. Will that person be able to understand what is it you're looking for? Yeah, Telangana Telugu. Yeah, Andhra Telugu. Yeah, I mean, almost the same, right? I mean, there may be a few words here and there, but that person can understand the overall context, right? Certain words are definitely different, so that we need to practice to understand, right? So what I'm trying to tell you is there is a language and that language has different variants. However, the other person will be able to understand, right? So here I'm talking about SQL variants. So which variant are we going to learn here is a TSQL variant. So we talk to our server using what? TSQL variant. Okay. So transact SQL, because our server name in the restaurant, there will be one name, right, to the server. Yes or no? Yeah, something like, let's say some A or B or Rahul or Ramesh or Ravi or some name will be there, right? Similarly, our server name is Microsoft SQL Server, right? In which variant of SQL I talk to my server? TSQL. Perfect. What am I here in this case? I'm a client. Client also should have a name, right? Even I have a name, right? So in my case, in the SQL Server side, the client name is SSMS, SQL Server Management Studio. I'm the client with the name SQL Server Management Studio. My server name is Microsoft SQL Server, and I use TSQL variant to talk to that person. Why do I need to talk to that person? Because I want some food. Here in the SQL Server side, I mean in the database side, what is it I need? I need some data. Perfect. I looked at the menu, right? Yes. What do I see in the menu? I see all the schema design, like how your database is designed, right? Perfect. I simply say a chicken biryani. So now the server job is to go to the kitchen. What is this kitchen here? Kitchen is your database. You see all the ingredients there? They are your tables, right? To get your food prepared, what is that? You need to mix different ingredients and prepare the food. Done. Here's the catch. Let's say you wanted to offer, what is that? Mixed veg curry. Okay. And in that you say that I don't want carrots. I don't want, what do we say? Potato, right? Rest everything is okay. I want less salt, more spice, half cooked, right? And you gave all these additional instructions. Okay, so when it comes to a food preparation, there is a standard method, but you can also place your special request, yes or no? And basis on that, your server understands that and it gets it processed. So here we go. Tell me something. When you are giving a lot of conditions like this, I want this, I don't want this, add more of this and less of this and do only this way, and I want this. Now you tell me, will it take more time than the regular request is processed? Yes, obviously. So that means more conditions if you include while placing your order, more time it takes. It's as simple as that. So sometimes your query may take more time because of the thing that you ordered with so much of complex conditions. Now you're getting it. So who are you? What's your name? SSMS, SQL Server Management Studio. And in which language you talk? TSQL. And to whom you talk to? Server. What's your server name? Microsoft SQL Server. And server goes to the kitchen, right? Kitchen is what? Database. All those ingredients are what? Your tables, your stored procedures, your synonyms, your indexes. So many things will be there. Okay. So your server job is to talk to the kitchen whosoever is a chef and nothing but your database environment there and gets your food processed, nothing but your data processed, comes back, delivers. Now you get it, the entire thing. Who is a client, who is a server, which language we are using, and where your data is getting processed, and what do we say in the database? What do we see in the database? Tables, views. These two things for now, you just remember tables and views. That's enough. There are so many other things also, we'll talk about that. So you have the restaurant server, database server, and we have the manager who is basically the admin of it. Okay, there is a database admin who basically oversees everything and has all the permissions. Okay, this is what kitchen versus database. Understand that all the tables, views, stored procedures, schema designs, and everything are there inside your database, and kitchen layout, pantry storage, ingredients, recipes, and everything. Right? Okay. So what's happening here? Taking the orders is nothing but you are running your queries. So the server takes the orders. Here you run your queries, right? So customer orders a mail, nothing but client sends a query. So server writes it down. So query gets passed, right? Kitchen prepares, data gets processed, food delivered, results are returned. Easy to understand. What is your name in this entire thing? Who are we? We are client, right? Client has a name. What is it? SSMS, SQL Server Management Studio, right? And what is the language we are using here? TSQL. And with whom we are talking to? A server. Server name is Microsoft SQL Server. Perfect. Server job is to take your order, goes to the kitchen, nothing but the database, gets your food processed, nothing but your data gets processed, and come back and return the result. Done. So the menu with the select commands and all, select, insert, update, and all that. We'll talk about that. See, overall, what is that we are doing here? We are completing one transaction code. Now I have a question. We are one of the clients in this entire story. Can there be multiple clients? Yes. So that means the server job is to serve all these clients. Okay, here we go. So server has multiple resources actually, multiple instances also. Depends on the way the servers are designed. A simple example is, let's say there are 10 tables. You have different servers to take their request and process. But hold on. Let's assume that you have 10 tables, but only one server is there. Possible? And sometimes you find in a restaurant, like, they say that the other servers are not available today, and I'm only alone working here, right? Now you tell me, would there be any latency issue and only one server is serving all 10 customers or 10 clients? Yes or no? Can you expect your food to be delivered just in 2 minutes? Like when 10 are working, 10 servers are working, and now one is only working. So definitely there will be delay, right? Yes. So why? Because only one server is taking care of multiple requests, right? Understand this. Sometimes when you run, usually any website or something, when you trigger a query, it's not in the form of a query, but you say that, okay, from this date to this date, I want to see all my transactions, and you click OK. Sometimes it runs that query really fast and gets you that output, but sometimes it takes like 2 minutes, 3 minutes. And then that's when, what do we say? That server is slow. Why the server is slow? Maybe because the server is already, taking care of so many other things from the other clients also, right? So when it happens, if the server is running out of the resources, or the server is trying to serve multiple requests that are coming parallelly, right, simultaneously, then yes, you find the server latency issues. Now you're getting the point. So if the server is busy doing so many requests, then you find the server latency issues, right? Okay. Customers coming, going, coming, going, only one server is there, coming, going, coming, going, coming, going, and the customers are still waiting in the queue, and only server is there, and doing. After a certain time, even the server feels like, okay, I'm done, I can't do this more anymore. Yes? Then, even if you try to submit a query, it doesn't even respond. What is it? Server is down. You hear these things, right? When do we say server is down? Okay, server is not at all responding to take any of your requests. Every query that we send, there is a timeout, a standard timeout. Okay, it waits like usually at 10 minutes timeout, and even after 10 minutes, if the server is not responding, the query will be terminated automatically because the server is down. It's not taking any requests anymore. You understand? But usually, if a restaurant server doing a lot of work gets tired and then yeah, is down is okay. But in the real time, the servers are down because of multiple reasons. If it is running out of resources or any power failure is there, something could be done, could happen there. Our operating system issue is there and the internet connectivity issue is there, right? Because of that, the servers may not be able to respond, right? Processor may be trying to process so many things and already, all the resources have been exhausted by serving multiple requests and there is no additional space to or resources to serve other requests, then that's also, at that point also the server won't respond. Too old means it depends on the technology. I understand, like, if someone has installed an older, the infra itself is very, very old. Let's say, I'll tell you one thing. There is a machine and that has only limited resources with a small processor, something like a P3 processor. Let's assume servers, we don't use, a regular processor like this. Servers have the different processors, but someone is using a P3 processor, old generation one. It has only about, let's assume only a 64 MB RAM, but we have installed that as a server there, right? The problem is that how many requests it can handle with the limited resources because of the system configuration. It can't handle so many things. It has its limitations, right? Yes, one thing is the technology side of it. The other one is the internet also. What if the internet connections are poor and the signal is not that good, right? The connectivity is not that good. That point also, the data transfer and all will happen really slow, right? What if the internet is completely disconnected? At that point also, you cannot reach the server. Okay. But here you no need to worry about reaching your server because the server we are going to install in our computer itself. Server will be there inside our computer. Client will also be there inside our computer. Databases will also be there inside our computer. Okay. But in the organizations, the server may be someplace and the database may be located near that server, right? And you may be connecting to that server using internet. Okay. We have this, right? LAN, local area networks, or WANs, wide area networks, and also using that, you can still reach your server. Okay. So basically, what we are trying to do here is, as a client, we look at the menu, talk to the server, gets the data processed. That's it. Now we know our name. We are the client. Client name is SQL Server Management Studio. Our server name is SQL Server. And the language name is TSTO. Okay, the variant. I hope you understood the entire thing now. Okay, here we go. Just take a look at this now. I think you can easily understand this. In this entire image, where are we? Where are we? This entire image, let's say you are a client. Where is this client? This person, correct. We are the client. Client uses an application, right? Can you name that application name? What is that name? Can you tell me the name? Application name. Client uses a client application. What is our client application name? SSMS. Right. We as a client, we use our client application, right? SSMS, SQL Server Management Studio. So what is that we do there in SSMS? We need to use a language to create a query, right? I'll do one thing. I'll just show you one simple example here. Even if you don't understand it, what's happening at this point, absolutely no need to worry. You will also be doing all these things like starting the server, stopping the server.
virtual server is also there in our computer.
Hmm.
So the server will be supposed to have a different kind of data IP.
Yes, sometimes what happens is that these servers, if they are a network-based server, something like they're not part of your computer, they're outside. So in order to connect to that server, you need to use the computer IP address to connect to it. Something like 103.104 dot, 198 dot something. Then you don't require any other machine IP address or something. It comes with the name. Directly you can use the name. Okay. So we'll see that how that name appears. Let me go to SSMS. This is our client application. I've connected to my server and my server name is this KK laptop. I named it like that. You can also rename it if you want. Okay. So I want to write a query on one of the databases. I'll write a very simple query here to do a data retrieval. I say that select star from employee. Okay. Right. So what did I do here? I wrote a query in my client application. I clicked on execute. What kind of a query I wrote? I wrote a data retrieval query. I can do other things also, data storage or administration report related or any other queries or data security related, any other queries I can write. But I wrote a data retrieval query. So where it goes to by DBMS, the database management system. That's our server. And what is the job of the server? It goes to the database. Which database is it? EMP database, employee database. Okay, EMP database. Inside that EMP database, there are so many tables. Different tables are there. And which table I am looking for the information or the data? Employee table. That's what I wrote here. Right? So the job of this database, okay, your database server is to go to the database. There are so many tables, but I'm looking for only small part of the data there, which is coming from the employee table. So it goes to that table and whatever the data is there, it picks it up and it shows it on my screen like this. Understood? So what is the application I'm using here? SSMS. And in which language I wrote it here? TSQL. SQL or TSQL to be specific. And which database am I working with here? EMP. And from the EMP, which table I wanted some data from? Employee. And what is the job of the server when I trigger this query? It goes to the database, goes to the particular table, and whatever the data is present as per my query, it is displaying it on my screen. That's what happening in the entire image. Right? Don't think only about always about a data retrieval query. SQL can do administration related, user security related, or data insertion or deletion related. All those queries can be executed using same SQL commands only. But why we only talk about data retrieval? Because as a data analyst, our job is to always, extract the data and create reports using the data. Understood? Got some clarity now about this image? Right. What are we here? Client. Client talks to server. Which language? SQL. Okay. What is the job of the server now? Whatever the request we placed, server gets it processed. That's it. I think you are comfortable with these, all the terminology, right? You know what is a language, you know what is a server, who is a client, what is a client application, what is a server application, which variant of SQL are we using, right? Done. So here we are using RDBMS, Relational Database Management System. all these things like SQL Server, MySQL, MS Access, Oracle, all of them are RDBMS only, relational database management systems only. Okay. The reason being all the data in these databases is stored in the form of tables that have the relationships. But if you want to call something as a relational database, there are rules proposed by EF code. If you remember the name, great. If not, also that's fine. EF code proposed 13 rules for any RDBMS. If you want to call something as RDBMS, there are 13 rules proposed. So it means the data is stored in multiple tables having relationships between them. Multiple tables having relationships among them using the keys and constraints. The rules are here in your instructions. If you can read, remember them, great. But if not, also it's okay. Why I'm saying it's okay, even if you don't remember them, the reason being, we are not going to develop any RDBMS. I mean, are we not? What is our job here? Do the data retrieval. That means by the time your server is there, your database is there, your data is there, and that's when our job starts. We are not here to create any new RDBMS system, right? Yeah, so that's the reason. But if you want to go through, just go through them. If you feel like, okay, learning more about RDBMS rules. But our job is not about creating RDBMS. Okay, it's up to you if you want to go through. Right. So why I want you to understand here in RDBMS, the data is stored in the form of tables that have relationships. And these relationships can be created using the keys and constraints. So what is a key and what is a constraint and all? We'll discuss that. But for today, I'll show you or I'll ask you a couple of questions and you can give the answer in the group, or you may want to wait until Monday to tell this answer. Here's the point. There are keys. Probably you would have heard a word like primary key. Anyone heard? Primary key. If not, also that's okay. Primary key, foreign key. Okay, fine. So let me keep it simple for you today. I want you to give me a few examples of primary keys. Okay. I can give you an example here, and after that, you can think about other examples and you may want to post it in the group. A primary key is something like unique and not null. Unique, nothing but it can't be duplicated and it cannot be null. The best example I would say employee ID, because most of you are working in your organization, you got one employee ID. So that is a primary key for you, right? In order to identify or track the details of the employee, this primary key helps. Okay. So primary key, the example I said is employee ID. So let us check. Is it unique? Yeah, because your employee ID cannot be given to anyone else. Yes or no? That's your employee ID. That's it. I have a question here. What if this employee leaves the organization? Can the same employee ID be given to anyone else? Yes or no? Yes or no? The same employee ID, can that be given to any other employee or not? Yes? No? Okay, why? No?
Because that particular employee ID
Hmm.
reserved for him or her.
Perfect. Yeah, it cannot be assigned to anyone else. Even that person leaves also. Why? Why? Because why we need to leave that employee ID alone there? Because what if a background verification check is happening for the employee who left that organization? Employee ID 123. But this organization assigned that 123 to someone else. When the other company comes for the verification, and can you just tell us the details of employee ID 123? Okay, employee ID 123 is Ravi. Okay, so Ravi, when they search their records, employee ID 123 is now showing, Ramesh, because they reassigned that employee ID. Now you see that this company goes back, says that, okay, no, Ravi is not there. It's not correct. The 123 is actually Ramesh. Then that's it. What happens to the employee who applied for the job in the other company? Gone. You get the point? So even if employee leaves the organizations, the primary keys will not be given to anyone else. Understood? Right. Okay. So it is not duplicated. Even if someone leaves, it is not deleted also. It cannot be reassigned or it cannot be deleted. Okay. So looks like employee ID is a good example for the primary key because it is not getting duplicated. And also an employee ID, if it is issued, no one can get a null or a blank employee ID, right? Yes or no? Definitely there will be a number. It can't be null. So two rules for a primary key. It must be unique and can't be null. Employee ID is the best example, right? Can we think about maybe a 5 or 6 primary keys? That's your exercise. You just look around. You see so many primary keys. Today onwards, let's learn the skill. You just look around every day, every time, everything that you do, you see a primary key there. If it is connected to any system, any application, you see a primary key there. I want you to identify that. Outside, anything, right? If you ask me, metro pillar itself is a primary key because it has got an ID, A series, B series to uniquely identify them. See, it's about you, how you want to read and understand from this outside world itself. You can understand so many things, okay? It's just that you need to relate to your subject, that's it. Restaurant itself, you can think about a database server and all that. It's a simple restaurant example, but you can turn the entire thing into your database environment, right? So for these 2 days, Saturday, Sunday, we don't have any sessions. So think about at least a 5 to 6 primary keys, and either you can mention them in the chat in your WhatsApp, or otherwise Monday we need to talk about that. And about advantage of SQL, one of those things in the controlling redundancy, inconsistency and all, indexing and all, there I'll talk about these keys once again. Then by the time you will be having a good idea about the keys. So that's the reason this exercise.
The entire number.
SIM card. SIM card. Mobile number you are asking about, or a SIM card, it has a serial number. Which one you are asking about? Mobile number, okay. Mobile number, is it a primary key? Okay, every mobile has got one unique identification number and cannot be duplicated and cannot be null. Okay, fine then. But the number is same, right? Okay, so certain cases you cannot reassign. So certain cases you can reassign. But I told you only 2 rules for a primary key. What is that I said? It must be unique and can't be null. At the given point in time, with one mobile number, how many mobiles can exist? Only one, right? Simple. Understood? So anything that is satisfying these 2 rules, something that is unique and not null, consider that as a primary key, and I want to see the list. Okay, as one single message, you can type all those things and send that list either in WhatsApp group or Monday I will discuss that. Okay, so with that, you will have a better idea when we start talking about the advantages of SQL. Okay, great then. So I'll end it here. So please try to find out a few primary keys. Okay. Done then. Online participants, any questions so far? Great then. Let's catch up on Monday. Thank you. Thanks everyone.